Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero series on Python machine learning algorithms. Alright guys, so this is lesson number 3 and I am going to talk about a new kind of algorithm which is widely popular in the ML industry called decision trees. So this is a pretty much widely used algorithm across the ML DL AI sector. There are ton loads of solutions being implemented based on the decision tree. It's a pretty simple logic to understand based on the booleans true or false, yes or no, zeros or one, right? I mean that's the way the systematically this algorithm works. So basically, the decision trees are constructed using an algorithmic approach that identifies ways to split a data set based on different conditions. Conditions is true or false, right? So it is one of the most widely used and practical methods for supervised learning. Decision trees are, basically a non-parametric supervised learning method used for both classifications and regression tasks. So you guys should definitely understand what is a classification and regression from a ML background. I expect you to understand. If you don't understand those things, please do reach out to me for one-on-one. I'll be happy to take dedicated classes for you. So going back to decision tree. So decision tree is a supervised learning technique that can be used for both classification and regression problems as well. But mostly it is preferred for solving a classification problem. It's widely used. The true or false or the booleans, this particular algorithm is used for classification problem. So it is a tree structured classifier where internal nodes basically represent the features of a data set, branches represent the decision rules, and each of those leaves, as you can see, are the node which represents the outcome, which is the output, right? So in a decision tree there are two nodes, so which are the decision node and the leaf node. As you can see the drawing above me, the decision nodes are used to make any decision and have multiple branches, whereas the leaf nodes are the output of those decisions and do not contain any further branches, right? So obviously within the leaf you cannot see any kind of branches growing in the tree, right? So that's one of the funny examples. So anyways, so jokes apart, so now let's move on to the Python code to execute the decision tree. So let me just open up my Visual Studio IDE and there you go, it's in here. So again we are using numpy as np as a keyword for numpy, and then we are basically defining the class called decision tree. And I don't have to explain these codes line by line, though there are a couple of explanations I have put in between in order to make you understand how it works and kind of thing. So this is about how many lines of code? It's about, let me just count, it's about 179 lines of code. So let me try to execute this particular code and see what happens, how this decision tree algorithm works. As an example, you might take this code and use for your own data sets in your machine learning project and execute, boom, you are ready with your ML project. Let me just run this code quickly. Alright, there you go. So the mean square error decision underscore tree init, 1 items passed, all tests, and 7 tests in mean squared, 7 tests in 9 items, 7 passed and 0 failed. Test overall result, test pass. Wow, fantastic. So the code seems to be working perfect. Now you guys are all set to take up this code and execute in your project. Alright guys, so that's about this short lesson. So these are the algorithms which is pretty much handy and useful for your machine learning project. So you can take this code from me, you can take this Python code from me, put in your data sets, whatever the data you are playing around with, whichever the ML project you are using, you are working on. Take the data, input the files into the decision tree algorithm, and you are ready. You are going to be ready to rock and roll, build your cool little machine learning project. Alright, I will see you soon in the next lesson with the next algorithm. See you. Goodbye.